Okay, so once again, good day everyone, and welcome back to another topic that we will be discussing for today. So for today's lesson, we will be discussing all about temperature, the different temperature scales, as well as thermal expansion. Okay, so let's first have the zeroth law of thermodynamics. So what is the zeroth law of thermodynamics? So we have here, zeroth law of thermodynamics states that, let's say we have three systems here in figure 17.2. So if C or system C is in thermal equilibrium with both A and B, then A and B are also in thermal equilibrium with each other. Okay, so when we say thermal equilibrium or two systems are in thermal equilibrium if and only if they have the same temperature. Okay, so we can say that the two systems are in thermal equilibrium if these two systems have the same temperature. So zeroth law of thermodynamics again states that if system C, let's say we have the third system C, is in thermal equilibrium with these two systems A and B, then also system A and system B are also in thermal equilibrium or have the same temperature with each other. Because again, here in figure 17.2, we have systems A, B, and C are connected with each other with a conductor, as well as here on the second figure with an insulator. So again, if the two systems, or we can say that the two systems are in thermal equilibrium if they have the same temperature. So again, that is the zeroth law of thermodynamics. Okay, so now let's discuss all about the thermometer as well as the different temperature scales. So the first one, we have the Celsius temperature scale. So Celsius temperature scale is a very common excuse me, very common temperature scale that we always use in measuring temperatures or body temperature, as well as let's say when we are baking. So we always use, or we commonly use, Celsius temperature scales in measuring the temperature of an object or of a body. So Celsius temperature scale is a temperature scale based on 0 degrees for the freezing point of water and 100 degrees for the boiling point of water. That's why we have 0 degrees Celsius if we have the freezing point or the freezing point of water, and we have 100 degrees Celsius for the boiling point of water. So that is Celsius temperature scale. So for the Celsius temperature scale, our unit will be in terms of degrees Celsius. So again, degree Celsius for the Celsius temperature scale. Okay, so now the second one is what we call the Fahrenheit temperature scale. So Fahrenheit temperature scale, the unit for this one is in terms of degrees Fahrenheit. So Fahrenheit temperature scale is a scale based on 32 degrees for the freezing point. Now take note, now for Celsius, it's 0 degrees, but for Fahrenheit, it's 32 degrees for the freezing point of water and 212 degrees for the boiling point of water. So the interval between the two being divided into 180 equal parts. And then we have the last one, which is the Kelvin temperature scale. So Kelvin temperature scale, the unit for this one is Kelvin, or capital letter K only. Wala na siya degree nga symbol. Only the Celsius and the Fahrenheit have a degree symbol before the unit or before the variable. So we have degree Celsius, degree, and then capital letter C. For Fahrenheit, we have the degree symbol and then capital letter F. But for Kelvin temperature scale, we only have capital letter K for the unit. Okay, so Kelvin temperature scale is 1 over 273.16, or it is equivalent to 3.6609 times 10 to the power of negative 3 of the thermodynamic temperature of the triple point of pure water. Okay, so let's find out what are their equations or formulas for us to be able to calculate for the these different temperature scales. Okay, so we have these conversion equations. So the first equation here, this one, equation number 1 is if you want to convert a temperature from degrees Celsius or from Celsius temperature scale to degrees Fahrenheit or the Fahrenheit temperature scale. So as you can see here, we have T sub C, which is the temperature in Celsius. T sub F is the temperature in Fahrenheit. And T sub K is the temperature in Kelvin. Okay. So T sub F, if you want to convert again from degrees Celsius, or if ang atong given is from degrees Celsius or temperature in Celsius, and if we want to convert that to Fahrenheit, we can use equation number 1. We have T sub F is equal to 9 over 5 times T sub C. So again, we need to multiply first 9 over 5 and T sub C before we add 32 degrees. Kaya if we add first T sub C plus 32 and then multiply by 9 over 5, we will get a different value. So again, it's really important to multiply first T sub C by 9 over 5 before adding 32 degrees. So this is the equation or conversion equation if we want to convert temperature from Celsius to Fahrenheit. Okay, so let's proceed to the second equation. This second equation is if we want to convert temperature in terms of Fahrenheit to Celsius. Okay, so we have T sub C, or the temperature in Celsius, is equal to 5 over 9. And then take note here na in this parenthesis, close open parenthesis, is the difference of T sub F and 32. So again, it is different with equation number 1. Sa equation number 2, we need to get the difference first, or we need to subtract T sub F and 32 first before multiplying it by 5 over 9. Okay, again, it's different if we multiply first T sub F by 5 over 9 and then subtracting it by 32 degrees. We will arrive with different answers. So the best way or the correct way is to get the difference first, or you subtract T sub F minus 32 degrees, and then your answer, the answer is you multiply it by 5 over 9. So that is for equation number 2, which is if you want to convert from Fahrenheit or degrees Fahrenheit to degrees Celsius. And then the last one, we have this equation will be used if we want to convert temperature in Celsius or degrees Celsius to Kelvin. So the temperature in Kelvin is equal to the temperature in Celsius, T sub C, plus 273.15. Okay, so there are other books na they are using 273, but here we will be using 273.15 so that our answers or our conversion will be more accurate. So again, we just add 273.15 to the temperature in Celsius so that we can get the temperature in terms of Kelvin. Okay, so let's have examples, or let's try examples on how to convert temperatures. So let's say, for example, we will convert 32 degrees Celsius to Kelvin. Okay, so atong given is in terms of Celsius and we want to convert it to Kelvin. So here, we will be using equation number 3. Okay, so we have T sub K is equal to, we have T sub C plus 273.15. So substituting the value of T sub C, we have 32 degrees Celsius plus 273.15. So our temperature in terms of Kelvin will now be, we have 32 plus 273.15 is equal to 305.15, and then don't forget the unit, which is Kelvin or capital letter K. So this is our answer for the conversion from Celsius to Kelvin. Okay, let's try another example. Let's say we have 102 degrees Fahrenheit to degrees Celsius. Okay, so it is from Fahrenheit to Celsius. So let's go back to the equation. Okay, so here, out of these three equations, we will be using equation number 2 to get the temperature in terms of Celsius. Okay, so temperature in terms of Celsius is equal to, we have 5 over 9, then open parenthesis, T sub F minus 32 degrees, close parenthesis. Okay, so we have 5 over 9 times T sub F is 102 degrees Fahrenheit minus 32 degrees. Okay, so now let's calculate. Let's subtract first. Let's write first 5 over 9. 5 over 9 times, we have 102 minus 32 is equal to 70. Okay, so 5 over 9, we have 5 over 9 times 70 is equal to 38.888889 or 89, and then we have degrees Celsius. So this is now the temperature from Fahrenheit. So 102 degrees Fahrenheit is equivalent to 38.89 degrees Celsius. Okay, so let's have last example, example number 3. Let's say we have 310 degrees Fahrenheit to Kelvin. Okay, so now take note na from degrees Fahrenheit to Kelvin, we don't have any equation or conversion equations. So what we will do is we will convert first Fahrenheit to Celsius, in which we will be using equation number 2. And then, since we now have, if naanatay value in terms of degrees Celsius, then we can use equation number 3 to convert from Celsius to Kelvin. So that's what we will do. Okay, so let's start first in converting from Fahrenheit to Celsius. Okay, so we have T sub C. We will be using equation number 2. 5 over 9 times T sub F minus 32 degrees. So we have again 5 over 9 times 310 degrees Fahrenheit minus 32 degrees. So our T sub C, if we will calculate this directly, we have is equal to 154.44 degrees Celsius. Okay, so now this is our temperature in terms of degrees Celsius. But again, we were asked to find for the equivalent temperature in terms of Kelvin. So, to get the temperature in terms of Kelvin, we will be using equation number 3. So, we have Tk or T sub K is equal to T sub C plus 273.15. So, T sub C is 154.44 degrees Celsius plus 273.15. So, the temperature in terms of Kelvin will now be 154.44 plus 273.15 is now equal to 427.59. And then again, don't forget to write the unit, which is Kelvin, or capital letter K. So our final answer, so 310 degrees Fahrenheit is equivalent to 427.59 Kelvin. Okay, so in converting temperatures, don't forget to put the unit. Okay, if you will not put the unit, then maybe even if ang etong gipangita, let's say T sub C, but then you didn't put any unit which is degrees Celsius, so I can write any unit that I want. So again, it's really important that you put a unit after the value so that mahibalaan gyud nato na it is the temperature in terms of Celsius, or temperature in terms of Fahrenheit, or temperature in terms of Kelvin. Okay. So now here, let's proceed to thermal expansion. So for thermal expansion, we have two types of thermal expansions. We have, the first one is the linear expansion, or we also call it as linear thermal expansion. And then the second one is the volume expansion, or volume thermal expansion. So let's start with linear expansion first, or linear thermal expansion. So for the linear expansion, it is all about the length, or expansion of the length of a material. So we have here our equation for the linear expansion. We have delta L is equal to alpha times L sub O times delta T. Now, who are these variables right here? So delta L is the change in the length of the material. So delta L, to solve for the delta L, or if we want to solve for the change in length, so again, when we say change or delta, it is the final length minus initial length. And then also we have alpha. So alpha is the coefficient of linear expansion. So when we say coefficient of linear expansion, it depends on what material are we using. So let's say, for example, for the steel, it's this some amount of value. For aluminum, it's different. For iron, it's different. So the coefficient of linear expansion for every material is different. And then we also have L sub O. So L sub O is the initial length of the material. And then we have delta T is the change in temperature, which is again final temperature minus initial temperature. So again, this is our general equation for the linear expansion. So delta L is equal to alpha times L sub O times delta T. Okay, so how about the units of each of these variables right here? So for delta L, or for the change in length, final length, and initial length, we will be using meter or meters as the unit, or basic unit. And for alpha, we have 1 over Celsius degree, or 1 over Kelvin. Now, asa manigikan si Celsius degree? So for delta T, or the change in temperature, our unit for the change in temperature, which is applicable only for the for the thermal expansion, we have Celsius degree. So let's say, for example, we are asked to solve for delta T. So let's say our final temperature is 60 degrees Celsius, and our initial temperature is 35 degrees Celsius. So our change in temperature now, so 60 minus 35 will be 25. So 25, but now the unit, instead of degrees Celsius, our unit now will be in terms of Celsius degree. So again, for delta T, or the change in temperature, our unit will be in terms of Celsius degree or Kelvin. Now, nganong Kelvin man? It's because we have this conversion right here for the unit for delta T. So 1 Celsius degree is equivalent to 1 Kelvin. So 1 is to 1 siya. So if our delta T is 25 Celsius degree, it is also equivalent to 25 Kelvin. So again, kani siya nga conversion is only for the thermal expansion and also for the heat. So later on after this topic, so the next topic will be all about heat. So we will also be using Celsius degree and Kelvin for as the unit for delta T. Okay, so take note na this one is different sa katong temperature conversion. Kay di ba? Temperature conversion, we have 1 degree Celsius is equivalent to 273.15 plus 1, which is 274.15 Kelvin. So this is different from 1 Celsius degree, which is equal to 1 Kelvin. So kani siya nga conversion is for the change in temperature only. So kani siya nga conversion is from degree Celsius to Kelvin. So again, this is different kay base maglibog mo. So again, we can use this conversion as for the delta T or the change in temperature only. Okay, so that is for the linear expansion. Now, how about for the volume expansion? So actually, the trend of the equation is the same for linear and volume expansion. Ang nakalahi lang niya is, since we are dealing with volume expansion, so obviously, from delta L, we change it to delta V, which is the change in volume. Beta, now from alpha, it becomes beta na for volume expansion. So beta is the coefficient of volume expansion. And then we have V sub O is our initial volume. And we have delta T as our change in temperature. So take note or notice na ang ilang trend sa equation is almost the same. So ang nakalahi ilang are the variables from length and alpha to volume as well as beta. Okay, so for the units also, we have for the change in volume, final volume, and initial volume, we will be using cubic meter or cubic meters, cubic centimeters, and also liter. So L, capital letter L is liter. Okay, and then we have beta. Same ang unit ni alpha and beta, which is 1 over Celsius degree or 1 over Kelvin, as well as for delta T, which is Celsius degree or Kelvin. Okay, so we also have this equation right here. Now, para asa man ni siya nga equation? Now, there are problems, let's say problems about volume expansion, na instead of beta ang ihatag, they are giving the value of alpha. So, that's why we have this equation right here, because again, our volume expansion of formula is using beta as the coefficient for volume expansion. So, if alpha ang given, we need to convert alpha to beta first. So, that's why we have beta is equal to 3 times alpha. Or also, if baliktad ang situation, if linear expansion ta, and then we are given the value of beta instead of alpha, so we can have alpha is equal to beta divided by 3. So it's either of these two, depending on the situation and what kind of expansion are we dealing with. Okay, so now let's try an example. So this example, or this first example, is an example of a linear expansion. Okay, so we have a surveyor uses a steel measuring tape that is exactly 50 meters long at a temperature of 20 degrees Celsius. So the markings on the tape are calibrated for this temperature. So what is the length of the tape when the temperature is 35 degrees Celsius. Okay, so here we are given the values 50 meters, we have 20 degrees Celsius, and we have 35 degrees Celsius. Also, by the way, aside from this given, we also have, wala lang nabutang sa problem, but the alpha for steel is equal to 1.2 times 10 to the power of negative 5 per Kelvin. Okay, so now, who is this 50 meters long? Okay, so before that, ang question here is, what is the length of the tape when the temperature is 35 degrees Celsius? So kung sa Bisaya pa, unsa man katas-a ang length or unsa man katas-a ang tape if ang temperature now is 35 degrees Celsius. So obviously, we are finding the final length of the steel. It's because see 35 degrees Celsius is our, you mentioned there is a question, sa problem na the tape is exactly 50 meters long at a temperature of 20 degrees Celsius. So, sa 20 degrees Celsius pa, ang iya ang length is 50 meters long. So, pila naman or unsa naman katas-a ang tape pag abot na sa temperature nga 35 degrees Celsius. Okay. So, we have our initial length is 50 meters. We also have our final temperature, which is 35 degrees Celsius, and our initial temperature, which is 20 degrees Celsius. Okay, so here, using the linear expansion formula, we have delta L is equal to alpha times L sub O times delta T. So again, we are asked to solve for the final length. Okay, so now what we will do, okay, since again wala man diri sa equation ng ato ang gipangita, so we will break down delta L in terms of initial and final length. Now take note na delta L is equal to the final length minus the initial length. Okay, so we will substitute this here. We have final length minus initial length is equal to alpha times L sub O times delta T. So we need to transpose minus L sub O to the right side of the equation so that we can solve for L. So we have L is equal to L sub O or positive L sub O plus alpha times L sub O times delta T. Okay, so before we solve for L, we need to solve first for delta T para plug in na lang dayon ng ato ang values. Okay, so delta T is again final temperature minus initial temperature. We have 35 degrees Celsius minus 20 degrees Celsius. So 35 minus 20 is 15 Celsius degree, or we can also have it as 15 Kelvin, because in our given sa alpha they are using 1 over Kelvin para it's easier to cancel out the unit. Okay, so we have, substitute na rin sa atong values, 50 meters plus for alpha we have 1.2 times 10 to the power of negative 5 per Kelvin times L sub O is again 50 meters, and then we have delta T is 15 Kelvin. Okay, so notice na for the units makancel out si 1 over Kelvin as well as the Kelvin here. So obviously we are left with the unit meter or meters for the length or the final length. Okay, so we have, let's try to calculate 50 plus, we have 1.2 times 10 to the power of negative 5 times 50 times 15. So, the answer is, or the final length of this steel is 50.009 meters. Okay, so take note here na from 50 meters, which is the initial length of the steel, after when we increase the temperature to 35 degrees Celsius, na-expand ang atong steel, and now our final length is 50.009 meters from the initial length, which is 50 meters. Okay, so that is for our first example. So now we proceed to another example, which is again for the linear expansion. We have the original length of one metal is 1 meter, and the final length is 1.02 meter. Okay, so let's write first the original length, which is the initial length, which is 1 meter, and the final length is 1.02 meters. So the change in temperature, which is obviously delta T, is 50 Kelvin. Okay, so the question now here is to determine the coefficient of linear expansion. Now, kinsa gani ni si coefficient of linear expansion? It is C alpha. Okay, so now here, going back or writing the formula for the linear expansion, we have delta L is equal to alpha times L sub O times delta T. So we are asked to solve for alpha. Okay, so what we will do is we divide both sides with L sub O times delta T para ang mabili na lang sa makancel out na siya. And then we have alpha is now equal to delta L divided by L sub O times delta T. Okay, so again, take note na we don't have any value for delta L, but we can solve for delta L because we have the value for the final and initial length, which is, we have delta L is final length minus initial length divided by, and then we have L sub O times delta T. So we can now solve for alpha. Okay, so substituting their corresponding values, we have 1.02 meters minus 1 meter divided by, we have L sub O is 1 meter times delta T is 50 Kelvin. So 1.02 minus 1 is 0.02 meter divided by 1 meter times 50, that's 50 meter times Kelvin. So obviously the meter unit will be cancelled out in the numerator and denominator. So we are left with Kelvin, or our unit for alpha will be in terms of 1 over Kelvin. Okay, so we have 0.02 divided by 50 is equal to 4 times 10 to the power of negative 4 per Kelvin. Or we can also have it as 4 times 10 to the power of negative 4 Kelvin to the negative 1. So Kelvin to the negative 1 is still the same with 1 over Kelvin. So again, our coefficient of linear expansion for this metal is equal to 4 times 10 to the power of negative 4 per Kelvin. Or we can also have it again as 4 times 10 to the power of negative 4 per Celsius degree. So they are still the same. Okay, so this is for our second example. And now, for our last example, it is all about the volume expansion na example. Okay, so we have at 30 degrees Celsius, the volume of an aluminum sphere is 30 cubic centimeters. So the coefficient of linear expansion is 24 times 10 to the power of negative 6 per Celsius degree. So now if the final volume is 30.5 cubic centimeters, the question here is, what is the final temperature of the aluminum sphere? Okay, so now let's write first the given values. We have the initial volume, V sub O, which is 30 cubic centimeters. We also have the final volume, which is 30.5 cubic centimeters. And then we also have coefficient of linear expansion. Now, coefficient of linear expansion is alpha. But take note na, we are dealing with volume expansion. So, alpha is 24 times 10 to the power of negative 6 per Celsius degree. So, from the equation of volume expansion, delta V is equal to beta times V sub O times delta T. So, we need the value of beta, but we have an alpha here, so we need to convert alpha into beta. Now, take note na, beta is equal to 3 times the value of alpha. So, we have 3 times 24 times 10 to the power of negative 6 per Celsius degree is equal to, so let's calculate, 3 times 24 times 10 to the power of negative 6 is equal to 7.2 times 10 to the power of negative 5 per Celsius degree. So this is now our value of beta, or the coefficient now of our volume expansion. So, and then we also have our initial temperature there, which is 30 degrees Celsius. So what we need to find is the final temperature. Okay, so let's go back to our volume expansion formula. So we need to break down delta T in terms of final and initial temperature so that we can solve for the final temperature. So we have delta V is equal to beta times V sub O times we have final minus initial temperature. Okay, so again, so we need to multiply beta times V sub O with initial and final temperature. So we have beta V sub O times final temperature minus beta times V sub O times initial temperature. Okay, so the next step is to transpose negative beta V sub O times T sub O to the left side of the equation. So we have delta V plus beta times V sub O times T sub O is equal to beta times V sub O times the final temperature. And then the last step will be to divide both sides with beta times V sub O on both sides so that it will be cancelled out here, and then we are left with the final temperature on the right side of the equation. So to solve for T is equal to delta V plus beta times V sub O times T sub O divided by beta times V sub O. Okay, so substituting their corresponding values, delta V, for delta V, we have final volume minus initial volume. So we have 30.5 cubic centimeters minus 30 cubic centimeters plus, we have our beta is 7.2 times 10 to the power of negative 5 per Celsius degree. And then V sub O is times 30 cubic centimeters, and then T sub O is 30 degrees Celsius. And then divided by Beta is again 7.2 times 10 to the power of negative 5 per Celsius degree times V sub O, which is 30 cubic centimeters. Okay, so we have 30.5 minus 30 is 0.5 cubic centimeters plus what we have right here for this one. We have 7.2 times 10 to the power of negative 5 times 30 times 30 is equal to 0.0648 divided by, so take note here na ma-cancel out C, the common unit between the numerator and the denominator is cubic centimeters and 1 over Celsius degree. So this will be cancelled out, obviously. And then, ang mabili na lang ay unit will be in terms of degrees Celsius. Okay, so for the denominator, we have 7.2 times 10 to the power of negative 5 times 30 is equal to 2.16 times 10 to the power of negative 3. Okay. So we are left with degrees Celsius here na unit. So the final temperature is, we have 0.5 plus 0.0648 divided by 2.16 times 10 to the power of negative 3 is equal to 201.48. Okay, and then we have the unit degrees Celsius. Okay, so this is for the final temperature of the aluminum sphere, if the final volume is 30.5 cubic centimeters, is now equal to 201.48 degrees Celsius. Okay, so I think that's it for our discussion, which is all about, again, temperature scales, as well as the linear expansion and the volume expansion. So thank you very much for listening and for watching our discussion video, and we will see you on the next topic. Thank you.